This one's Todd, though.
Hi, everybody. Hi, I'm Todd. This is Mike. So our original talk was 5 quick tips to secure your app, but they put both of us on this talk, and it turns out that when you throw more people at a project, you can get way more done in the same amount of time. So that is solid project management advice that you should take home with you. But to get through all 10, we're going to need to talk fast. I apologize in advance to our note taker, but Mike, why don't you start us off?
Let's do it.
All right.
Cool. So the thesis of all this talk, as you probably already know, when you build an app using Firebase, well, when you build an app without Firebase, you have a lot of complexity to deal with, right? You're doing your own OAuth, you're writing your own authorization, you have to deal with security patches on your servers, all that nonsense, right? When you go to Firebase, a lot of that complexity goes away, right? We're updating the OSs, we're updating our databases so that you don't have to do that. But there are still some things that you have to deal with when it comes to securing your app, right? You have to deal with authentication and authorization, right? We give you Firebase Auth, but how do you configure that appropriately to make sure that your app is secure? How do you do schema validation or business logic or other kinds of things of that nature? So we're going to start off with these tips by tip number 0 in good computer science form. Never trust anything on your client, right? This comes up a lot. People build their application, they write all their logic client side, and they just assume that everything is going to be fine. Well, you can't do that. So we'll actually start from the beginning. I hear a lot of questions about this. I actually heard a couple out in the Ask Firebase area. So when you start building a web app, for instance, you'll include this configuration script. And that has keys and other URLs and things that everyone comes up and they say, oh my God, if someone takes this, they're going to hack my entire database. Everything is going to be terrible. This talk, and actually, because as you can see, Firebase talks directly to resources. So in this case, we're just talking directly to Firestore based on the information above. Yes, that is technically the case. Someone can pull open your HTML or take your app apart and get that. But if you follow the tips that we have here, you're going to secure your information server side so that that's not going to be an issue. So back to Todd talking about Auth.
All right, so tip number 1 is, in spite of what we just told you, you can actually trust the auth information that's coming from your client, which I know is a little weird because we tell you like, hey, all this information that comes from the client, you cannot trust it. Don't believe any of it. Oh, but by the way, this request.auth object that we've got attached to it, totally trustworthy. And people are like, well, wait, that doesn't make any sense. Well, how does that work? And so I'm going to present to you an overly simplistic guide to how Firebase Auth works. So in general, when your user signs in from a third-party source like Facebook or Google or Twitter, you get back some information about the user, which you're free to use on the client. You can get their display name and their ID and their avatar URL. But as far as the server is concerned, this has been on the client. We no longer trust it. So in addition to this information, you get back an access token. And this is sort of basically a big opaque string that when your user says, hey, I'm going to sign in with Firebase, the Firebase client sends that along to the server. And then your server uses that to make a server-to-server call to the original identity provider and says, hey, is this person really who they say they are? This other service says, yes, I can verify that using this giant string that I've sent over, and everything is good. The problem is we can't make this network call like every time your user wants to read an element from the database. So instead what we do is once you've signed in, we say, great, here's your Firebase ID, and take this with you. This is your ID token, which is a giant string in the form of a JOT. And what is a JOT, you might ask? Well, it is a giant base64 encoded string that's got some information in it. You got a header. And then you've got some data which actually contains the information about the user you're interested in, like what their ID is and their display name and how they originally signed in and so on. And then you've got a signature, which is basically a hash of this data that has been encoded with Firebase's private key. And then by using our public key, our server, or really any other server out there, can verify that this data is correct and has not been messed with. If somebody does try and alter this data somehow, that signature will no longer match up, and then we'll know, OK, this data isn't valid. And so in the future, when your client is sending down requests to Firebase, the client library is going to send along this JOT, this ID token. Now, our servers can quickly and locally verify that all the data in that signature is valid. All that data in the JOT is valid. We verify the signature. And we know that this data has come from something that we've previously verified through a server-to-server call. Therefore, we can actually trust this auth information in our security rules, which is a fantastic segue to...
Thanks, Todd. So we've talked about authentication, which is who your user is, and verify that we can trust that. So security rules are the things on our database and storage products that allow you to understand what a user can do. So As previously mentioned, it's what stands between your client and our databases and storage servers. It provides what is known as attribute-based access control. So basically a set of attributes about the user, the request being made, the resource being accessed, that you can then write expressions about to get some result. So it's useful. We're going to kind of talk about this app a little bit more. It's a simple project management app. So we have the name of a project, we have a status, and then we'll actually have an owner as well of the string of the user who created the project. And let's try and actually kind of lock this down. And when we talk about protecting this application, we actually mean several things. So we talked about authentication already. Let's assume that we have that done. We're going to authorize the user to make sure, hey, maybe only they can access a certain project. But there are a couple other things that we want to do. One, we want to validate the schema, right? We don't want people arbitrarily adding extra data to our project. We want to ensure that only those fields of a project are there. And then we also want to validate our business logic, right? Maybe we have business logic that our client has implemented to say only certain people can change the project from public to private and vice versa. We want to ensure on the server that those rules are also in place. And when you combine all of those together, all of those have to succeed and you get an allow or deny decision coming out of that. So let's walk that through. So authorization is the first thing that we're going to do. And in our simple app, we're going to write the following rules. So if a project is public, so if that string is public, anyone can read, but only members can write. And then if the project is private, only members can read and write. So let's see how we would implement that using Cloud Firestore security rules. So for those of you who haven't seen Firestore security rules, it starts at the top with this service, which is just declaring this is what we're using, Cloud Firestore. And then we have path matchers. So the top is just a string that identifies the database. And then we have a collection called projects and documents by project ID. So this is matching all projects within the projects collection. And then we can have these allow statements. So we can say allow read, allow write, or in the future we'll allow more granular ones that I'll actually show on the next slide. And we're going to translate the English sentences that I wrote into these kind of attribute-based access control type conditions. So we're going to say if the resource data status, so that the fields of that document are public, anyone can read it. Or, again, translating that, if it's private, either the creator or someone who's a project member, which that's just a function call that I'll show in the future. We have to make sure that they're allowed. And then write, as I mentioned, again, they have to be an owner or a member of the project. Okay, so I talked about the is project member field. So there's another really popular kind of field of access control called role-based access control. And so that is kind of what people normally think of when you use Drive or Photos. It's there is some user that wants access to some resource and you give them a concrete role. So reader, owner, editor, admin, and that gives them this set of permissions. So there are a couple ways of handling that in Firebase, because we don't give you, the is member lookup somewhere else. So there are a couple ways of doing this. You can add users as a list in every document. You could create a sub-collection, or Todd will actually show us in a minute how you can add custom claims and why you may or may not want to use that. Also, feel free to go check out the link. We have a solutions paper on how to implement this in Firestore if you're interested. But I could imagine a very simple one where I've actually taken that second option and I have another sub-collection under my projects collection that has the users who are members of that project. And then I can write a function that says is project member, it takes a user ID, and all it does is it looks up data from another place in Firestore to see if a user is in there. There's actually a little bit more nuance there that I'll show at the end because we have a video. You have to deal with, say, bootstrapping that of how do you get the first user in there or who has permissions to add more users. But it's nice in that once you kind of do those initial security rules, you can build on them very quickly. Okay, tip number 3, so validating your schema. We've dealt that only the correct people can actually kind of view or edit it, but how do you know that those people, once they're in, aren't doing malicious things? Right? There are a few things that you want to do when you validate schema. You want to make sure that required fields are there, and optional fields, if they are being provided, are correct. So in our case, we're going to require status, project, and owner. We want to make sure that they're the only fields being provided, and we also want to make sure that they are always provided. We're going to do type checking as well, so we're going to make sure that all things are strings, but you can imagine that people have timestamps or geopoints or other things. And then lastly, we're going to add some allowed values or ranges. So for instance, status can only be the strings public or private. Project, we want to impose limits, and the owner must be the auth owner user ID. Again, we have the kind of similar, and I've actually removed the authorization part, but you would just and that in. So on create, again, we're going to check the size is 3, so only those properties exist, that all 3 properties are of the correct type, And then we can add our ranges, our checks, and the other kind of little business logic that we have. As I mentioned earlier, you can do granular things here. So I've actually broken out create. You would copy some of this for update as well, and then for delete, obviously, you don't need to validate schema on delete. We have a really cool tool here. Has anyone heard of a protocol buffer? They're really popular at Google. Wow, that's actually way more people than I thought. So a protocol buffer is basically a way of describing a schema. So over here, what we've done is we've described this protocol message project that has status, project and owner. They're all strings. They're all required fields. And we have a tool at the link that will actually auto-generate those rules for you. So we will auto-generate the rules. And one of the other really cool things about protocol buffers is we can auto-generate client library classes as well. So your model objects can get pulled directly from that proto. So if you go to that link, we have an open source project that will generate all of your rules, as well as JavaScript, TypeScript, Objective-C, Swift, Java, and a couple other classes. So you can actually keep your client-side code in sync with what is being validated on your server. It's really, really cool. So that'll make your life a little easier. We'll just give you the isProject message function that you can use to check that immediately. OK, lastly, so we've done authorization. We've done some schema validation. Let's also do a quick business logic check. There are some questions that are brought up around, for instance, how would you have editors update things, or how would you have people actually change a project from private to public? We can add kind of a simple check here. Imagine if someone wants to update it. You can take the existing data, which is resource.data, and you can check it against the data that someone is proposing, which is request.resource.data. If they're different, so if someone is trying to change from public to private, let's actually add this other collection. So we had a users collection earlier. Let's also add this admins collection. Make sure that if someone is trying to change both of those, that they're an admin. It's kind of a simple way, but again, you can extend these concepts to do a lot of really, really interesting things from an authorization perspective. As I mentioned earlier, shameless plug number one of this, we've done a video where we walk through all of this. We also talk through how to do bootstrapping, so how to get that first user in to ensure that the kind of whole system is set up securely. So if you go to the link, you can watch me for another, I think, 9 minutes, talk you through all of this.
All right. I think we have to talk even faster.
We do, yeah.
All right, here we go. Tip number 5, watch out for gotchas. So security rules, they're great. They do have a few gotchas. One of the most common, this phrase we use, rules are not filters. Or maybe to put it another way, rules validate queries, not data. And to explain what we mean here, let's take a look at our projects collection again, right? We've got a couple of projects that we've said, OK, these are public, and one, this salmon colored, that we've said it's private. And then, let's say we want to create some rules that say, OK, well, you can only read these projects if their status is public. Now, some people think, well, OK, if my client were to request all their projects from this collection, well, security rules would do this really neat thing where they might automatically filter out all the documents that I'm not allowed to see. But in fact, it does not work this way. We can't do we can't have security rules change the results you're getting. We can either accept or reject the entire request, and that's it. And I think most people understand that. The part where it gets a little trickier is sort of the second layer. Yes, this request would be rejected. The second layer here, so let's imagine now that all of our projects are public, right? So yay, they're all readable. Now, you might expect that this request would now be allowed, right? But the thing is, with Cloud Firestore, we need to make sure these requests are fast. You might be doing real-time updates on thousands of documents. And we don't have time to have security rules investigate every single document in a query. So we have to say, can we prove that this request would be allowed without looking at any of the data underneath, right? And in this case, we can't. There might be some private projects here. And so this request would be rejected. So instead, what we would do to fix this is say, OK, well, just give me all the documents where the status is equal to public. And sure, in this case, that equals all of the documents in a collection. But the nice thing is, by looking at the security rules, we can prove, without looking at the data, that this request would be allowed. And we're happy. Now, just a reminder, this really only applies to queries where you're fetching large numbers of documents from a collection. If you're doing something like a write or fetching from one individual document, then yes, we can take a look at the data. But for queries, we have to kind of prove it without actually taking a look under the hood. All right, tip number 6, custom auth claims are super useful sometimes. So custom auth claims are basically kind of custom key value pairs that you would write that would be associated with auth information for a particular user. You generally write this using server-side code, your own server code or cloud functions. And in this case, like we are setting this custom isAdmin key equal to true for this particular user. Now, right, there's nothing special about isAdmin. It's just sort of a variable that we basically made up. But what happens is when we set a custom auth claim, do you remember those ID tokens, those JOTs we talked about earlier? Well, Firebase Auth will go ahead and add its own custom value, whatever custom values you've supplied to this ID token, right? Then it'll go ahead and kind of re-sign it. And then in the future, when your client says, hey, I need a fresh ID token for this particular user, well, now we can deliver this new JOT, this new ID token, with all the new custom values baked right in, one that's, again, been verified and signed on our servers so we can trust it. So we can set up rules that say, hey, you know what? Read any of the data in my app if this special, super secret isAdmin key is equal to true. And then, when our client makes a request, we pass down this JOT, we verify that it's true, and we look at this and say, oh, according to our custom auth claims, this user is an admin. And we can go ahead and allow them to read all the data in our database. And so your reaction is, wow, this is great. I'm going to start using custom auth claims for everything. But hold your horses. That's an expression. There are a few restrictions here. First, you're limited to a total of 1,000 bytes of information that you can set in custom auth claims. And second, you may need to wait up for an hour for the token to refresh for these changes to take effect. So in general, I think the best situation for custom auth claims are like database-wide auth stuff. Things where you're like, hey, I want to set some employee in my company to be an admin or to be a moderator where they can read or write all the documents at a particular level. For sort of fine-level access control, it's like, hey, this user just joined a chat room and now I want to give them access to all the documents in the chat room. Don't use custom auth claims. I think you're better off sticking with sort of the role-based access control that Mike talked about earlier. And if this 30-second explanation wasn't enough for you and you want more, Jen Person did a fantastic video and blog post all about this topic, and I encourage you to check it out for more information. All right,
cool.
Moving on.
Thanks, Todd. So we've talked a lot about authentication and rules and the crazy gotchas. You want to make sure that you're testing your rules because I understand there's a lot of content going on. So we've provided 2 ways that you can start doing this. One is by simulating your rules in our console. So when you go to Firestore, the real-time database, or storage, you can see this simulator. As you can see, we let you do simulate all the different types of operations, so create, update, delete, etc. You can provide a location, you can build data, you can provide custom auth claims. So in this case, we're going to add an anonymous UID that I've created a document for. So I create a document with that UID, so I'm going to be the owner. I have project bits, status bits, etc. So I can actually try and simulate running that against the data that is stored. And in this case, it's going to be allowed because that create rule allowed it. Notice how I don't have an update rule, though. So if I change my operation to an update, it's going to fail and tell me a little bit about why that failed. So very nice, especially if you're doing one-off or want to do kind of data that is currently existing in your database to simulate that out. The other one is a local emulator that we launched this morning. And so that looks something like this. So I guess you don't actually have to sign up at that link anymore. It should be available. But you can essentially write node tests. So in this case, we have an emulator. I'm giving it my auth UID. And then I can write, for instance, gets on a private document and a public document, and then write assertions to say whether or not they're going to succeed or fail.
All right, moving on to tip number 8. Consider cloud functions. So my general philosophy is cloud functions are generally better than overly complex security rules. So as you are developing, look for cases where your security rules have just sort of gotten more and more complex and have more and more exceptions to them, and see if there's a way you can simplify that by essentially replacing it all with a function. And let me explain a little more about what I mean. Imagine I got a multiplayer chess game, right? And basically every document in this games collection is a game that's going on between a couple of people. Now, if we wanted a client to make a move in this chess game, we could sort of update our game document, but there's a bunch of stuff we'd have to check here to make sure this is legit. Like, is this move legal? And was it even this player's turn? And are they making a move in the right game? And is this game board actually the result of what would have happened if they had made this move, right? There's a lot of stuff that you have to check. And in theory, you could kind of do this with some very complex security rules, but I am not a fan of very complex security rules. Like the more complex the rules are, the generally the easier it is for someone to break it or for a bug to sneak in. And these things are kind of living on the front lines of your app. People are actively trying to break them and see, what holes there are in them. And, let's face it, security rules, they're kind of hard to develop because, you don't have things like variables or if-then statements or, console logging or any of that fun stuff. So in general, what I would recommend is lock down. In this case, we're going to lock down our games collection. Like no client is allowed to write to it at all. It's going to be read-only for certain situations. And instead, I'm going to create a completely separate pending moves collection, and I'm only going to let my client add very simple documents, right? Their user ID, the game they want to make a turn in, and what move they want to make. And then we can write a cloud function that looks for any new documents created in this collection. When it finds one, it says, great, I'm going to go ahead and calculate a new state for this chess game and write it to the games collection. Now, because cloud functions run server-side, they run in an environment that you can trust, so it's allowed to bypass your security rules. So you can keep nearly everything locked down and let your cloud function do most of the heavy lifting. And by the way, it's great not just for multiplayer chess games, but basically anywhere you have denormalized data in general. Like if you think about it, this little player's entry probably has a whole bunch of denormalized data, like duplicate data that we have stored elsewhere in a user's collection. And if one of our players wants to change her name, we don't really want our client to have to go and find every individual game and allow security rules that make an exception where, okay, maybe you can change your name, right? That's just going to get messy. Instead, have a cloud function that, again, looks for changes in your user's collection and fans out those changes elsewhere in your database. All right, tip number 9, listen to the warnings. So, okay, we know when everyone develops, your security rules look a little like this. And yeah, that's fine, because ideally your process is, okay, I'm going to open up my database, I'm going to get stuff working, then I'm going to lock down and secure my database, and then I'm going to ship it. But I know, all right, this step, not really sexy. You don't get a lot of fun new features out of it by the end of it. Really, your app will work exactly the same as before. You've just spent a lot of time on it. So I think a lot of developers maybe go through this process instead, and then, oh, wait, did I remember to fix our security rules? I better go and secure that, right? And okay, don't do this, right? Because if you're not careful, someone is going to notice between steps 4 and 6 that your database is not secure, and your app will make the news for all the wrong reasons. So we've started surfacing in a few places, areas where we're trying to remind you that your database is not secure. You'll see this little icon in the rules tab, and you've got this big banner now across the top of the rules page that reminds you that you left your database open to the world. We've also started sending out emails, right? If anyone's had their database available for a while, we've noticed it's insecure, and you're getting a fair amount of traffic, we will send this email. And so I guess if you have one piece of advice, one big takeaway from this presentation, it's that don't ignore this email, right? If you have received this email, stop what you're doing right now and run out of the room and go and secure your database.
Please don't do that.
Well,
actually, maybe.
Okay.
Or come talk to us afterwards.
All right. Tip number 10, keep your employees on a short leash. Not literally. Again, my apologies for people for whom English is not their first language. That's a strange idiom, and I don't actually recommend that as a business practice. But I know we're all worried about the evil hacker or the disgruntled employee who sabotages our system. But really sort of an equally valid concern is this guy. It's Joe's second day on the job, and oh no, I accidentally deleted all our customer data because that delete button is really easy to click on, and sorry. So it used to be that, Joe, it's his second day, he just wanted to create an A/B test, right? And if we wanted Joe to be able to create an A/B test, we would have to give him editor access. But that means not just write access to, analytics and our A/B dashboard, but, write access to everything. They could, delete customer data or change all your security rules or, turn off different auth methods and all sorts of stuff that Joe didn't have to do. So now, you may have seen this, we've added the ability to assign users particular Firebase roles where they can either read or write to certain sections of the Firebase console. So now we can tell Joe, hey, you have access to create A/B tests by creating a couple of remote config parameters. You can view analytics. You can create your own A/B experiments. But hey, guess what? You can't erase or even view really any of our customer data, any of our security rules, any of our crash information, any of that. And so certainly if you're adding new folks to your Firebase project, make sure you've added the right rule. But also for your currently existing products, see if maybe there's folks on your team who might have too much access and kind of scale it back a little bit. So I think we made it, like, according to the timer, we have 41 seconds left. So we are pretty much out of time. If you have questions, first go onto YouTube and like rewatch this video at 0.75 speed. And then after that, talk to me and Mike in the Ask Firebase Lounge. We're going to be hanging out there right after this. And you can find links to a lot more info right here in the Firebase Events app. And with that, thank you very much. Whew.